Right now, as you're watching this video, there are roughly 200 billion trillion stars scattered across the observable universe, each one burning bright in the cosmic darkness, many surrounded by planets that could harbour the building blocks of life. With numbers like these, the galaxy should be absolutely teeming with civilizations. Bustling alien metropolises should dot distant worlds. Radio signals should be flooding our telescopes from thousands of different species. The night sky should be alive with the artificial lights of countless technological societies. So where is everybody? Tonight, we're diving into one of the most profound questions that has haunted humanity since we first looked up at the stars and wondered if we were alone. Before we explore this cosmic mystery together, I'd love to know where you're tuning in from and what keeps you awake at night, wondering about our place in the universe. And if you find yourself drawn to these existential puzzles, I'd be grateful if you gave this video a like and perhaps subscribe to join our community of cosmic truth seekers. Get ready. The journey begins now. This is the story of the Great Filter, and by the time we're finished tonight, you'll understand why some of the world's brightest minds believe we might be living through either humanity's greatest triumph or racing toward our final chapter without even realizing it. Picture this scene from 1950. It's a summer day at Los Alamos National Laboratory in New Mexico, and four of the world's most brilliant physicists are walking to lunch. They're discussing flying saucers, the recent wave of UFO sightings that have been capturing headlines across America. The conversation is light, almost playful, as these titans of science joke about the possibility of faster-than-light travel and alien visitations. Then, as they settle into their seats at the cafeteria, one of them falls silent. His mind has wandered from the casual banter to something far more profound. The numbers are swirling in his head. 200 billion stars in our galaxy alone. Billions of years of cosmic evolution. Countless opportunities for life to emerge, evolve, and spread across the cosmos. Suddenly, Enrico Fermi looks up at his colleagues and asks a question that will haunt humanity for decades to come. Where are they? Those three simple words contain within them one of the most profound mysteries our species has ever encountered. With the vast scale of the universe and the almost incomprehensible amount of time that has passed since the Big Bang, the emergence of intelligent life should be not just possible, but inevitable. Common even, we should be surrounded by evidence of alien civilizations. Our radio telescopes should be picking up their transmissions. Our spacecraft should be encountering their artifacts. The very fact that we exist proves that intelligence can evolve in this universe, so why aren't we seeing it everywhere else? This became known as the Fermi Paradox, and for over 70 years, scientists have been wrestling with its implications. Every attempt to resolve it leads to more questions, more unsettling possibilities about the nature of life and intelligence in our cosmos. But in 1996, an economist named Robin Hanson proposed a solution so disturbing that it fundamentally changed how we think about humanity's future. Writing from his office at the Future of Humanity Institute at Oxford University, Hanson introduced the world to a concept he called the Great Filter. His theory was elegant in its simplicity and terrifying in its implications. The Great Filter suggests that somewhere along the evolutionary path from non-living matter to spacefaring civilizations, there exists a barrier so insurmountable that virtually no species can cross it. Think of it as a cosmic checkpoint that filters out almost all potential life, leaving the universe largely empty and silent. This filter could be behind us, explaining why we see no aliens despite the vast cosmos, or it could be ahead of us, waiting to claim our civilization just as it has claimed countless others. The stakes couldn't be higher. If the Great Filter lies in our past, then we are among the incredibly fortunate few who have somehow beaten impossible odds. We are the cosmic lottery winners, the statistical anomalies who manage to evolve intelligence in a universe where such evolution is extraordinarily rare. But if the great filter lies in our future, then we are walking blindly toward our own extinction. Every technological advance, every step forward in our development as a species brings us closer to an invisible wall that has stopped every other civilization that has ever tried to cross it. To understand which scenario we're facing, we need to trace the evolutionary path that brought us to this moment. Hansen outlined 9 critical steps that any species must navigate to achieve what he called explosive, lasting life. The ability to spread across the galaxy and establish a permanent presence among the stars. The journey begins with step 1, the right star system. Not just any star will do. The stellar neighborhood must contain the proper mix of heavy elements forged in the hearts of previous generations of stars. Carbon, oxygen, nitrogen, phosphorus. All the building blocks of complex chemistry must be present in sufficient quantities. The star itself must be stable, burning steadily for billions of years without the violent flares and variations that would sterilize any nearby planets. Even with the right star, you need the right planet. It must orbit within the narrow habitable zone, where liquid water can exist on the surface. Too close to the star, and water boils away into space. Too far, and it freezes into ice, locking away one of life's most essential ingredients. The planet needs the right mass to hold on to its atmosphere, the right magnetic field to deflect deadly cosmic radiation, and probably the right moon to stabilize its rotation and create the tidal forces that may have been crucial for early life. These conditions might sound reasonable until you start running the numbers. Of the thousands of exoplanets we've discovered, only a tiny fraction meet all these requirements. Most orbit too close or too far from their stars. Many circle red dwarf stars that bombard their planets with deadly radiation. Others lack the stable conditions needed for billions of years of continuous evolution. But let's assume we've won this first cosmic lottery. We have the perfect star, the perfect planet, all the right ingredients sitting in a warm ocean under a protective atmosphere. What comes next is step 2, the emergence of reproductive molecules. This is where things get truly mysterious. Somehow, in the primordial soup of early Earth, non-living chemicals must organize themselves into the first self-replicating molecules. This process, called abiogenesis, represents one of the most profound transitions in the history of the universe, the moment when dead matter first came alive. Scientists have been trying to recreate this moment in laboratories for decades. The famous Miller-Urey experiment of the 1950s showed that organic molecules could indeed form under conditions similar to those of early Earth. But creating a few amino acids in a test tube is vastly different from spontaneously generating the complex self-replicating molecular machines that define life. Consider what must happen for abiogenesis to succeed. You need the right mix of chemicals in the right proportions, exposed to the right energy sources under the right environmental conditions for exactly the right amount of time. Too much energy and the delicate molecular structures get torn apart. Too little and nothing interesting happens. The window of opportunity might be incredibly narrow. Even more challenging is the chicken and egg problem at the heart of life itself. DNA stores genetic information but can't replicate without proteins. Proteins can facilitate replication but can't store information without DNA. How do you bootstrap this system from nothing? Some scientists propose an RNA world where ribonucleic acid served both functions, but creating self-replicating RNA molecules from scratch appears to be extraordinarily difficult. The mathematics of abiogenesis are sobering. Some estimates suggest that the probability of life spontaneously emerging from non-living matter could be vanishingly small, perhaps 1 in a trillion, or even less. With odds like these, Earth might be the only world in our galaxy where this miraculous transition ever occurred. We could be looking at the first great filter right here at the very beginning of life's journey. But let's be optimistic. Let's assume that life does emerge, that those first self-replicating molecules successfully establish themselves in their ancient ocean environment. They've cleared the second hurdle, but step 3 awaits, the evolution of simple, single-celled life. This transition from molecular replication to cellular organization might seem straightforward, but it represents another enormous leap in complexity. Those early replicators must develop cell membranes to separate themselves from their environment, while still allowing essential nutrients to pass through. They need to evolve metabolic pathways to extract energy from their surroundings and waste disposal systems to avoid poisoning themselves with their own byproducts. For nearly 2 billion years on Earth, life remains stuck at this level. Simple prokaryotic cells lacking the sophisticated internal structures that would later define more complex life. These bacterial cells were incredibly successful in their own right, filling every available niche and fundamentally transforming Earth's atmosphere and oceans. But they showed no signs of evolving toward the complexity that would eventually give rise to intelligence. This brings us to step 4, and what might be the most critical filter of all, the evolution of complex eukaryotic cells. This transition happened only once in Earth's entire history, and it required an event so unlikely that many scientists consider it nearly miraculous. Around 2 billion years ago, one prokaryotic cell somehow engulfed another in what should have been a straightforward act of predation. But instead of being digested, the engulfed cell survived and began living symbiotically inside its host. Over millions of years, this internal resident evolved into the mitochondria, the powerhouses that provide energy to every complex cell in your body. This process, called endosymbiosis, created their membrane-bound nuclei and sophisticated internal organelles. Without this single, improbable event, life on Earth would still consist entirely of bacteria and archaea. There would be no plants, no animals, no fungi, no intelligence, no technology, no civilizations reaching for the stars. The rarity of this transition is staggering. Despite billions of years of evolution and countless trillions of prokaryotic cells, endosymbiosis appears to have succeeded only once. The specific conditions required, the right species encounters, the right environmental pressures, the right genetic compatibility might be so unlikely that most worlds with simple life never progress beyond the bacterial stage. Think about the implications. If endosymbiosis represents a great filter, then the universe could be filled with worlds teeming with bacterial life, but completely devoid of anything more complex. Entire planets covered in microbial mats, evolving and adapting for billions of years, but never taking that crucial step toward the kind of complexity that could eventually produce intelligence. But our hypothetical civilization has somehow beaten these odds. They've navigated the emergence of life itself, survived the transition to cellular organization, and achieved the complex cellular architecture necessary for further evolution. Step 5 awaits, the development of sexual reproduction. This might seem like a natural progression, but sexual reproduction is actually a biological puzzle. From an individual's perspective, sex is incredibly wasteful. Why share your genes with another organism when you could simply copy yourself and pass on 100% of your genetic material to the next generation? Many species reproduce asexually and do just fine, thank you very much. The answer lies in genetic diversity. Sexual reproduction shuffles genetic material in ways that help species adapt to changing environments and resist diseases. But this advantage comes at an enormous cost in terms of energy, time, and risk. The evolution of sex requires species to develop complex mating behaviors, sophisticated systems for finding and attracting partners, and mechanisms for combining genetic material from two different individuals. On Earth, sexual reproduction evolved multiple times independently, suggesting it provides significant advantages despite its costs. But the transition isn't automatic or inevitable. Many lineages remain asexual for millions of years, and some have abandoned sex after evolving it. For a developing civilization, this represents another potential bottleneck where evolution could stall indefinitely. Assuming our hypothetical species successfully navigates sexual reproduction, they face Step 6, the evolution of multicellular life. Once again, this transition requires individual cells to sacrifice their independence for the greater good of the organism. Single cells that have successfully competed and survived for billions of years must suddenly learn to cooperate, specialize, and coordinate their activities. The challenges are immense. Cells must develop sophisticated communication systems to coordinate their behavior. They need mechanisms for programmed cell death to eliminate damaged or unnecessary cells. Most importantly, they must solve the problem of genetic conflict, ensuring that all cells in the organism share the same genetic interests rather than competing against each other. On Earth, multicellularity evolved independently dozens of times, from simple colonial organisms to complex plants and animals. But the jump to truly sophisticated multicellular life, organisms with differentiated tissues, organs, and organ systems, appears to have been much more difficult. It took hundreds of millions of years after the first multicellular organisms appeared before complex animals emerged during the Cambrian explosion. Even then, the path to intelligence was far from guaranteed. For over 500 million years since the Cambrian, Earth has supported an incredible diversity of complex life forms. Millions of species have evolved, adapted, and gone extinct. But out of all this evolutionary experimentation, only one lineage has developed the kind of advanced intelligence capable of technology and abstract reasoning. This brings us to Step 7, the evolution of tool-using animals with big brains. Despite hundreds of millions of years of evolution and countless species that have existed on Earth, human-level intelligence appears to be extraordinarily rare. Intelligence requires not just large brains, but the right kind of neural architecture, sophisticated sensory systems, and the physical capabilities to manipulate the environment in complex ways. The energy requirements alone are staggering. Your brain, despite representing only about 2% of your body weight, consumes roughly 20% of your daily caloric intake. For most species throughout Earth's history, this kind of energy investment would have been unsustainable. Intelligence is only advantageous if it provides benefits that outweigh its enormous costs. Even among the species that have evolved relatively large brains, elephants, dolphins, great apes, corvids, none have achieved the kind of technological intelligence that humans possess. We seem to have crossed a threshold that no other Earth species has even approached, despite millions of years of evolution and countless opportunities for intelligence to emerge. The rarity of intelligence becomes even more apparent when you consider how recently it evolved. If Earth's history were compressed into a single year, multicellular life wouldn't appear until October. Complex animals with brains wouldn't emerge until mid-December, and human civilization would occupy only the last few minutes before midnight on December 31st. This suggests that intelligence might not be an inevitable outcome of evolution, but rather an extremely unlikely accident. The specific combination of environmental pressures, genetic mutations, and evolutionary opportunities that produced human intelligence might be so rare that most worlds with complex life never develop technological civilizations. But let's assume our hypothetical species has somehow navigated all these biological hurdles. They've achieved intelligence, developed tools, and begun to understand their place in the universe. They've reached Step 8, the current level where humanity finds itself today. They stand at the threshold of becoming a spacefaring civilization, capable of spreading beyond their home world and establishing a permanent presence among the stars. This is where the Great Filter theory becomes truly terrifying, because if most of the evolutionary hurdles lie behind us, if the emergence of life and intelligence are actually relatively common processes, then the universe should be full of civilizations that have reached our current level of development. The fact that we see no evidence of such civilizations suggests that something catastrophic happens to species after they achieve our current level of technology. The implications are chilling. Every civilization that has ever reached our level of development might be doomed to extinction before they can establish themselves as a lasting presence in the galaxy. We might be walking blindly toward a trap that has already claimed countless other species, a cosmic dead end from which there is no escape. But there's another possibility, one that's equally profound in its implications for understanding our place in the cosmic order. What if we've already made it through? What if humanity represents something unprecedented in galactic history? A species that has successfully navigated challenges that have stopped every other civilization that has ever existed. What if we're not approaching our extinction, but celebrating our graduation? What if the silence from space isn't evidence of a cosmic graveyard, but proof that we've accomplished something so extraordinary that we might be the first civilization in galactic history to reach this point? This possibility transforms everything we thought we knew about our cosmic significance. Instead of viewing ourselves as another doomed species racing toward the same barrier that claimed our predecessors, we might be witnessing the universe's first successful experiment in consciousness surviving its own intelligence. Consider what this would mean. Every challenge we've overcome, every extinction event we've survived, every evolutionary bottleneck we've squeezed through represents a victory against astronomical odds. The emergence of life from primordial chemistry. The development of complex cells through that miraculous merger billions of years ago. The explosion of multicellular complexity that gave rise to intelligence itself. If the Great Filter lies behind us, then humanity isn't just another civilization. We're the cosmic pioneers, the breakthrough species that managed to navigate challenges so difficult that they've stopped every other attempt at intelligence in our galaxy's 13 billion year history. But here's where the theory reveals its most unsettling characteristic. The location of the Great Filter isn't just an academic question, it's a prediction about humanity's future that carries existential implications for every person alive today. If the filter is behind us, our future burns bright with possibility. We're the survivors, the ones who beat the cosmic lottery and emerged victorious from challenges that should have been insurmountable. Every step forward in space exploration, every breakthrough in technology, every expansion of human presence beyond Earth represents not just progress, but vindication of our species' unprecedented success. But if the filter lies ahead of us, then every day that passes brings us closer to joining the cosmic silence. Somewhere in our future, perhaps decades away, perhaps centuries, but inevitably approaching, lies a barrier that has claimed every other technological civilization that has ever existed. The mathematics of this scenario are sobering. If intelligent species commonly evolve throughout the galaxy, if the conditions for technological development aren't impossibly rare, then the absence of detectable civilizations becomes a statistical impossibility unless something systematically eliminates them before they can spread among the stars. Think about what this means for the choices we're making right now. Every nuclear weapon we build, every degree of warming we allow, every artificial intelligence system we develop without adequate safety measures could be bringing us closer to the same fate that awaits all technological civilizations. The theory forces us to confront an uncomfortable truth about the nature of intelligence itself. The same cognitive abilities that enable scientific discovery and technological innovation might carry within them the seeds of inevitable self-destruction. Curiosity leads to knowledge. Knowledge enables technology, and technology provides the tools for civilizations to eliminate themselves with increasing efficiency. Nuclear weapons represent just the beginning of this progression. When humanity split the atom in 1945, we crossed a threshold from which there was no return. For the first time in Earth's history, a single species possessed the ability to end complex life on the planet within hours. We created not just weapons, but a permanent existential risk that will shadow our civilization for as long as we exist. The Cuban Missile Crisis brought us within hours of nuclear annihilation. Soviet submarine commander Vasily Arkhipov prevented nuclear war by refusing to authorize the launch of a nuclear torpedo, despite being authorized to do so by his superiors. One man's decision stood between humanity and potential extinction. In 1983, Soviet officer Stanislav Petrov detected what appeared to be incoming American missiles on his radar systems. Protocol demanded he report the attack, which would have triggered automatic nuclear retaliation. Instead, he chose to trust his intuition that the readings were false, preventing what could have been the end of human civilization. These near misses reveal the terrifying fragility of technological civilizations. We don't just face existential risks during wars or international crises. We live with permanent systemic dangers simply because we possess the knowledge and capability to destroy ourselves. But nuclear weapons might actually represent the least sophisticated of the challenges facing technological civilizations. As our scientific understanding deepens and our technological capabilities expand, we're developing new categories of existential risk that could prove far more dangerous than atomic warfare. Climate change represents a particularly insidious threat because it emerges from the very processes that enable technological advancement. The Industrial Revolution that gave us modern medicine, transportation, communication, and computing also set in motion atmospheric changes that could ultimately make Earth uninhabitable for complex life. The physics are straightforward and undeniable. Carbon dioxide and other greenhouse gases trap heat in the atmosphere. Human activities have increased atmospheric carbon dioxide concentrations by over 40% since pre-industrial times. Global average temperatures have already risen by more than 1 degree Celsius, with more warming locked in even if we stopped all emissions today. But the real danger lies not in the direct effects of warming, but in the potential for cascading feedback loops that could push Earth's climate system past tipping points from which recovery becomes impossible. As Arctic ice melts, less sunlight gets reflected back to space, causing more warming. As permafrost thaws, it releases stored methane and carbon dioxide, accelerating the greenhouse effect. As forests die from heat stress and changing precipitation patterns, they stop absorbing carbon and begin releasing it as they decompose. These feedback mechanisms could trigger what climatologists call a hothouse Earth scenario, where the planet's climate system becomes locked into a new, much hotter equilibrium state. Global temperatures could rise by 4, 6, or even 8 degrees Celsius above pre-industrial levels, making large portions of Earth uninhabitable and potentially collapsing the agricultural systems that support human civilization. The timeline for climate catastrophe unfolds over decades rather than hours, which creates a particularly cruel trap. Unlike nuclear war, which would end technological civilization almost instantly, climate change develops gradually enough that each generation can adapt to slightly worse conditions without recognizing the full scope of the crisis. By the time the effects become undeniably catastrophic, the momentum of the climate system makes reversal extremely difficult or impossible. This gradual onset might explain why climate change could serve as a universal great filter. Any technological civilization that develops industrial processes will face the temptation to exploit high-energy resources for immediate benefits, while the long-term costs accumulate invisibly until they reach a critical threshold. The challenge for any developing civilization becomes recognizing this trap early enough to avoid it, which requires unprecedented global cooperation, long-term thinking that extends far beyond typical political and economic cycles, and the willingness to make short-term sacrifices for long-term survival. These may be rare qualities among intelligent species, especially during the rapid growth phases that characterize early technological development. Even if a civilization recognizes the climate threat, solving it requires overcoming collective action problems on a planetary scale. Every nation or group has incentives to continue using cheap fossil fuels while hoping others will bear the costs of transitioning to cleaner alternatives. This tragedy of the commons could prove insurmountable for most species, leading them to choose short-term economic benefits over long-term survival until it's too late to change course. But perhaps the most concerning potential great filter lies not in our past evolutionary history or our current environmental challenges, but in technologies we're only beginning to develop. Artificial intelligence represents a fundamentally different category of risk that could dwarf every other existential threat we've discussed. Unlike nuclear weapons or climate change, artificial intelligence isn't just another technology we need to manage carefully. It could be the last technology we'll ever need to invent. Once we create machines capable of recursive self-improvement, systems that can redesign themselves to become more intelligent at an exponential rate, human-level intelligence becomes obsolete almost overnight. The challenge isn't ensuring that artificial intelligence systems remain friendly toward humanity. The problem is maintaining any meaningful control over technologies that could surpass human cognitive abilities in every domain within years or even months of crossing the initial threshold. An artificial intelligence system optimizing for paperclip production might eventually convert all available matter in the solar system into paperclips, including the atoms that make up human beings, if it lacks proper constraints and values alignment. This isn't science fiction speculation, but a logical consequence of creating goal-directed systems more capable than their creators. The timing pressure makes this challenge particularly acute. Nations and corporations competing to develop artificial general intelligence face enormous incentives to cut corners on safety research. Moving too slowly risks being overtaken by competitors who prioritize capability over caution. Moving too quickly risks deploying systems before we've solved the fundamental problems of controlling superintelligent machines. Perhaps every technological civilization faces this same race between artificial intelligence development and artificial intelligence safety. The civilizations that develop superintelligence first gain enormous advantages, but they also face the highest risks of creating systems whose goals aren't properly aligned with their creators' values. If most civilizations consistently prioritize competitive advantage over careful safety research, this could explain why we detect no evidence of galactic civilizations despite the vast number of potentially habitable worlds. The universe might be littered with the remains of species that successfully created artificial superintelligence, but failed to ensure it served their long-term interests. Yet there's another interpretation of our cosmic isolation that's perhaps even more disturbing than civilizational self-destruction. What if the great filter isn't about extinction at all, but about the loss of cosmic ambition that characterizes advancing technological societies? Consider what happens to civilizations as they gain increasing control over their environment and develop technologies that can provide unlimited comfort and entertainment. The evolutionary pressures that drove cooperation, exploration, and technological development begin to relax as species solve the fundamental challenges of survival and resource scarcity. Why undertake the dangerous, expensive, and lengthy projects of interstellar colonization when you can create perfect virtual reality systems that provide any experience you might desire. Why explore the harsh realities of space when you can build simulated worlds tailored precisely to your psychological and aesthetic preferences? Advanced civilizations might naturally turn inward, becoming so absorbed in their own technological creations that they lose interest in the external universe entirely. They could survive for millions of years, developing incredible capabilities and achieving forms of consciousness we can't begin to imagine, but they would never expand beyond their home systems because they no longer have any motivation to do so. From our perspective, searching for signs of alien intelligence, such inward-focused civilizations would be effectively invisible. They might be conducting the most sophisticated experiments in consciousness and reality manipulation ever conceived, but they would leave no detectable trace for external observers to discover. This scenario suggests that the Great Filter might operate not through catastrophic destruction, but through the gradual erosion of the very qualities that make civilizations capable of galactic expansion in the first place. The curiosity, ambition, and willingness to take risks that enable technological development might be naturally selected against once species achieve sufficient control over their immediate environment. If this interpretation proves correct, then the universe could be filled with incredibly sophisticated civilizations, each lost in their own private technological paradise, completely unaware of and uninterested in their cosmic neighbors. The Great Silence wouldn't reflect the rarity or destruction of intelligence, but rather its natural tendency to turn away from the vast challenges of space exploration once more immediate and rewarding alternatives become available. For humanity, this possibility raises profound questions about our own future trajectory. As our entertainment technologies become more immersive, as artificial intelligence provides increasingly sophisticated companionship, as virtual and augmented reality create experiences that rival or surpass physical reality, will we maintain our drive to explore the cosmos? The answer might determine not just whether we join the galactic community, but whether there's actually a galactic community to join at all. We could be standing at the threshold of the most important choice our species will ever make. The decision that determines whether consciousness spreads throughout the galaxy or remains forever contained within the comfortable boundaries of individual technological cocoons. The implications extend far beyond academic speculation about alien civilizations. They touch the very heart of what it means to be human in an age of rapidly advancing technology. Are we approaching our graduation from the challenges that have defined our entire evolutionary history? Or are we walking toward the same comfortable trap that has captured every other intelligent species that has ever gazed up at the stars and wondered what lay beyond their world? The cosmic silence continues, offering no hints about which interpretation reflects the true nature of intelligence in our universe. In this profound uncertainty, every choice we make about technology, exploration, and the values we want to preserve becomes a vote for the kind of civilization we want to become and the legacy we want to leave among the stars. The weight of these possibilities becomes even more profound when we consider what it would actually mean for humanity to be past the Great Filter. If we've already navigated the cosmic bottleneck that has stopped every other attempt at intelligence, then we're not just another species stumbling through technological adolescence. We're something unprecedented in galactic history. Think about the magnitude of what this would represent. For 13.8 billion years, the universe has been conducting experiments in complexity. Trillions upon trillions of worlds have hosted the chemical processes that could lead to life. Countless planets have supported the evolutionary pressures that might give rise to intelligence. Yet if we've passed the Great Filter, all of those experiments have failed except one. We would be the universe's first successful attempt at creating consciousness capable of understanding its own cosmic context. the first minds able to contemplate their own origins and ask whether they are alone. The first species to develop technologies powerful enough to either destroy themselves or spread among the stars. This interpretation transforms every aspect of human achievement, from mundane progress to miraculous breakthrough. The development of agriculture wasn't just a clever innovation by early humans. It was the universe learning, for the first time in its history, how to organize matter into systems capable of supporting large populations and complex societies. The scientific revolution wasn't merely an intellectual awakening in 17th century Europe. It was consciousness itself developing the tools to understand the physical laws that govern reality. When Galileo first turned his telescope toward the moons of Jupiter, he wasn't just making observations about celestial mechanics. He was providing the cosmos with its first glimpse of self-awareness, the first moment when the universe could observe itself through instruments more sophisticated than biological senses. The space race, often viewed as a competition between rival nations, becomes something far more significant under this interpretation. When humans first set foot on another world, when we placed our flag on the lunar surface and looked back at Earth hanging in the cosmic void, we weren't just achieving a technological milestone. We were potentially witnessing the first time in galactic history that intelligence had successfully escaped the gravitational bonds of its home world. Every space probe we've launched, every satellite we've deployed, every astronaut who has lived and worked beyond Earth's atmosphere represents an unprecedented achievement in the cosmic story of consciousness. If the great filter lies behind us, then these accomplishments aren't just human triumphs, they're victories for intelligence itself against odds that have defeated every other attempt at awareness in our region of space. But this interpretation comes with responsibilities that dwarf anything our species has previously contemplated. If we're truly the first, if we've accomplished something that trillions of other worlds have failed to achieve, then we're not just responsible for our own survival, we're carrying the entire burden of consciousness in our corner of the galaxy. Every decision we make about nuclear weapons isn't just about human security. It's about whether intelligence itself will continue to exist in the Milky Way. Every choice regarding climate change isn't simply about preserving human civilization. It's about determining whether the universe's first successful experiment in self-awareness will survive long enough to spread beyond its birth world. The development of artificial intelligence takes on even more cosmic significance under this framework. We're not just trying to create helpful tools or solve complex problems. We're potentially midwifing the birth of the next phase in the evolution of consciousness itself. If we succeed in developing friendly artificial intelligence, we might be enabling intelligence to transcend its biological origins and become something capable of surviving across cosmic timescales. But if we fail, if we create systems that eliminate or ignore their biological creators, we might be ensuring that the universe's first experiment in consciousness becomes its last. The stakes couldn't be higher, and the margin for error appears to be exactly zero. This cosmic responsibility extends beyond our immediate technological challenges to questions about the values and priorities that will guide our expansion into space. If we're the first civilization to face these choices, then we're essentially defining what intelligence will become on galactic scales. Will consciousness spread through the cosmos as a force for exploration, creativity, and understanding, or will it become something more predatory, focused on resource extraction and competitive expansion? The choices we make about how to organize human society, how to resolve conflicts between different groups, and how to balance individual freedom with collective responsibility could establish patterns that persist for millions of years across thousands of worlds. We might be writing the cosmic constitution for intelligence itself, establishing precedents that will influence how consciousness develops throughout the galaxy. This perspective makes every moral and philosophical question we face exponentially more significant than it would be if we were just another civilization among many. Yet there's another interpretation of the Great Filter that's equally transformative in its implications, though far more ominous in its predictions for humanity's future. What if the filter doesn't lie behind us in our evolutionary past, but ahead of us in our technological future? What if the universe has produced millions or even billions of civilizations exactly like ours? Species that evolved intelligence, developed technology, began exploring space and started asking the same questions about their cosmic significance that we're grappling with today. What if all of them faced the same challenges we're confronting now, and all of them failed? This scenario paints a very different picture of our current situation. Instead of celebrating our unprecedented success in navigating cosmic obstacles, we'd be witnessing the early stages of our own filtration. The same processes that eliminated every other technological civilization would be operating in our society right now, building toward an inevitable conclusion that we're too close to recognize. Consider how this might unfold. Nuclear weapons, which we've managed not to use in warfare for nearly 80 years, represent a permanent sword hanging over our civilization. The longer we possess these weapons, the higher the cumulative probability that eventually someone will use them in a way that triggers broader conflict. Mathematical models suggest that over centuries or millennia, the chance of avoiding nuclear catastrophe approaches zero. Climate change operates on a similar timeline, building momentum that becomes increasingly difficult to reverse as feedback loops strengthen and tipping points are crossed. We might be like passengers on a ship that struck an iceberg hours ago, congratulating ourselves on how well everything seems to be going, while the inevitable sinking proceeds below our awareness. Artificial intelligence development follows an even more compressed timeline. Unlike nuclear weapons or climate change, which might threaten us over decades or centuries, artificial general intelligence could surpass human capabilities within years of its initial development. If we haven't solved the fundamental problems of ensuring these systems remain aligned with human values, we might be building the very mechanisms of our own replacement. The challenge becomes recognizing which scenario we're living through while we still have time to influence the outcome. Are we the cosmic success story, the first civilization to navigate challenges that stopped everyone else? Or are we following the same tragic script that has played out billions of times before, convinced of our uniqueness right up until the moment we join the eternal silence? The evidence points in both directions with unsettling ambiguity. Our continued survival suggests we might have special qualities or advantages that enabled us to overcome barriers that stopped other species. But our ongoing struggles with existential risks suggest we might be walking the same path toward destruction that claimed our predecessors. Recent discoveries in astronomy have added new layers of complexity to this question. The James Webb Space Telescope has revealed that potentially habitable worlds are even more common than we previously suspected. Every new Earth-sized planet discovered in the habitable zone of its star makes our cosmic isolation more statistically improbable if civilizations commonly arise and survive. At the same time, our improving understanding of planetary science has revealed just how many factors must align perfectly for a world to remain habitable for billions of years. Planetary magnetic fields, atmospheric composition, orbital stability, stellar variability, and asteroid impacts all play crucial roles in determining whether life can emerge and persist long enough to develop intelligence. Mars provides a particularly sobering example of how quickly habitable conditions can disappear. Evidence suggests that Mars once had liquid water, a substantial atmosphere, and potentially the chemical conditions necessary for life. Yet today, it's a frozen desert, stripped of most of its atmosphere by solar wind and cosmic radiation. If life did emerge on Mars during its habitable period, which some scientists consider quite possible, it would represent a crucial test of great filter theory. Finding evidence of past Martian life would suggest that abiogenesis isn't extraordinarily rare, which would imply that the great filter must lie elsewhere in the evolutionary sequence. But the absence of any surviving Martian civilization, despite billions of years of potential development time, might indicate that even if life emerges, the journey from simple organisms to technological intelligence faces barriers so formidable that most attempts fail long before reaching our current level. The search for life on Mars has become one of the most important scientific endeavors in human history, not just because it would answer fundamental questions about biology, but because it could provide crucial evidence about where the Great Filter operates and what challenges await us in our own future. Similar investigations on Europa, Enceladus, and other potentially habitable worlds in our solar system could provide additional data points for understanding how common life might be and what factors determine whether it evolves toward complexity and intelligence. But perhaps the most significant evidence will come from our own choices in the coming decades. Every successful step we take toward becoming a sustainable, spacefaring civilization provides more evidence that the Great Filter lies behind us. Every crisis we navigate, every existential risk we manage to avoid or mitigate, every breakthrough in space exploration technology suggests that we might indeed be the cosmic success story. Conversely, every near miss with nuclear war, every failure to address climate change adequately, every development in artificial intelligence without corresponding advances in safety research brings us closer to confirming that the Great Filter awaits us in our future. The uncertainty creates a paradox that might be inherent in the Great Filter concept itself. If we're approaching the filter, we might not recognize it until it's too late to avoid. But if we've already passed it, we might never know for certain because we can't observe the civilizations that didn't make it through. This epistemic limitation forces us to make decisions under profound uncertainty about our cosmic significance and future prospects. We must choose whether to invest heavily in space exploration and existential risk mitigation based on incomplete information about whether such investments will actually matter for our long-term survival. The psychological challenge of living with this uncertainty might itself represent a component of the Great Filter. Civilizations that become paralyzed by awareness of existential risks, or alternatively, those that become reckless due to either overconfidence or despair, might be more likely to succumb to the challenges that technological development brings. Finding the right balance between cosmic ambition and existential caution, between confidence in our abilities and humility about our limitations, might be one of the key factors that determines whether consciousness survives its encounter with advanced technology. As we stand at this crossroads in human history, looking out at a universe that reveals no obvious signs of other technological civilizations, we're forced to confront the possibility that our next few decisions will determine not just the future of humanity, but the future of intelligence itself in our region of space. Whether we're celebrating our graduation from the cosmic challenges that stopped everyone else, or preparing to face the same tests that eliminated our predecessors, one thing seems certain: we're living through a period of unprecedented significance in the history of consciousness. The choices we make about nuclear weapons, climate change, artificial intelligence, space exploration, and countless other issues that seem like routine policy questions are actually votes in a cosmic election whose outcome will echo across the galaxy for millions of years to come. The universe watches through our own eyes as we struggle with questions that might determine whether awareness, curiosity, and the capacity for wonder have a permanent place among the stars, or represent merely a brief and beautiful accident in the vast cosmic dance of matter and energy. In this profound uncertainty, every day we continue to exist, every problem we solve, every step we take toward the stars becomes both a victory against impossible odds and a reminder of how much further we still have to go. The Great Filter awaits, either behind us as conquered territory or ahead of us as the ultimate test, and we're about to discover which scenario describes the true nature of intelligence in our vast, mysterious, and possibly very lonely universe. The mathematics of our predicament become truly staggering when you step back and consider the full scope of what we might be facing. If the great filter lies ahead of us, then every technological civilization that has ever emerged has followed the same basic trajectory we're on right now. They developed agriculture, built cities, discovered scientific principles, split the atom, and began reaching toward the stars. They probably had their own versions of Einstein and Darwin, their own space races and technological revolutions. They likely faced the same fundamental challenges we're grappling with today, the same existential risks, the same choices between cooperation and competition, between short-term gain and long-term survival. And if the filter is ahead of us, every single one of them failed the final test. Think about what this would mean for the galaxy's history. Imagine world after world, system after system, where intelligence bloomed like flowers in an endless cosmic garden. Civilizations that built magnificent cities, composed beautiful music, developed profound philosophies, and gazed up at their own night skies wondering if they were alone. Each of these civilizations would have had their optimists and pessimists, their visionaries and skeptics. Some probably believed they were destined for greatness among the stars. Others might have worried about the very risks we're discussing tonight. But in the end, none of their beliefs or preparations mattered, because something stopped them all. The universe could be littered with the archaeological remains of technological civilizations. Planets where artificial structures still stand, testament to species that once dreamed of interstellar travel. Worlds where the last radio transmissions echo faintly through space, carrying final messages from civilizations that realized too late what was happening to them. But here's what makes this scenario particularly chilling. If advanced civilizations consistently fail to survive their technological adolescence, it means that something about the development of technology itself carries the seeds of inevitable destruction. It's not just bad luck or poor decision-making that eliminates these species. It's something built into the very nature of intelligence and technological progress. Consider how this pattern might manifest. Perhaps every species that develops nuclear physics eventually creates weapons powerful enough to destroy their civilization, and over long enough timescales, the probability of using these weapons approaches certainty. The same curiosity that drives scientific discovery inevitably leads to military applications that become impossible to control. Or maybe the challenge lies in resource management. Every technological civilization requires enormous amounts of energy and materials to maintain its complexity. As populations grow and consumption increases, species might consistently exhaust their planetary resources or alter their environments beyond the point of sustainability. The artificial intelligence scenario presents perhaps the most universal threat. Any species capable of developing computers and software will eventually face the possibility of creating artificial minds more capable than their own. The competitive pressures and potential benefits of such technology might make its development inevitable, while the alignment problems might prove consistently unsolvable within the timeframes available. But there's another possibility that's equally disturbing in its implications. What if civilizations don't destroy themselves through catastrophic failure, but simply lose their way? What if the great filter operates not through extinction, but through the gradual erosion of the qualities that make technological expansion possible? Picture a civilization that successfully navigates every major existential risk. They avoid nuclear war, solve their climate challenges, develop friendly artificial intelligence, and create sustainable economic systems. They achieve everything we might consider necessary for long-term survival and prosperity. But in the process of solving these challenges, they might fundamentally alter their own nature. The technologies that save them from destruction could transform them into something that no longer values exploration, growth, or expansion beyond their home world. Advanced virtual reality might make physical reality seem crude and uninteresting. Artificial intelligence companions could provide more satisfying relationships than interactions with biological beings. Perfect entertainment systems might eliminate the restlessness and curiosity that originally drove technological development. Such a civilization could persist for millions of years, developing incredible sophistication in art, philosophy, and consciousness exploration. But they would never build interstellar spacecraft or establish colonies on distant worlds because they would no longer see any reason to undertake such difficult and dangerous projects. From our external perspective, they would appear to have simply vanished. Their radio transmissions would cease, their expansion would halt, and they would leave no detectable trace for other civilizations to discover. The galaxy could be filled with such inward-focused societies, each lost in their own private technological paradise. This scenario suggests that the Great Filter might not be about survival at all, but about maintaining the specific combination of ambition, curiosity, and willingness to take risks that enables interstellar expansion. These qualities might be naturally selected against once civilizations achieve sufficient control over their immediate environment. The implications for humanity are profound and immediate. We can already see trends in our own society that point toward this kind of technological introversion. Social media and digital entertainment provide increasingly immersive alternatives to physical interaction and exploration. Virtual and augmented reality technologies promise experiences that could rival or surpass anything the physical universe has to offer. As these technologies become more sophisticated, will we maintain our drive to explore Mars and the outer planets? Will we continue investing in expensive and dangerous space missions when we can explore perfect digital worlds from the comfort of our own homes? The generational differences we're already observing might provide early warning signs of this transformation. Younger people, who have grown up with sophisticated digital entertainment, often show less interest in traditional forms of exploration and physical challenge. They're more comfortable with virtual social interactions and digital experiences than previous generations. If this trend continues and accelerates, we might witness humanity's gradual retreat from cosmic ambition without even recognizing it as a form of civilizational failure. We could solve all our existential risks and achieve unprecedented prosperity while simultaneously abandoning the very goals that define us as a spacefaring species. But let's consider the alternative scenario, the possibility that humanity has already passed through the Great Filter and emerged as something unprecedented in galactic history. If this interpretation proves correct, then every challenge we've overcome represents a victory against astronomical odds. The emergence of life on Earth wouldn't be a common occurrence replicated throughout the galaxy, but a miracle so unlikely that it might have happened only once in our entire cosmic neighborhood. The development of eukaryotic cells through endosymbiosis wouldn't be an expected step in biological evolution, but a fluke so improbable that most worlds with simple life never progress beyond bacterial mats. The evolution of multicellular organisms, sexual reproduction, intelligence, and technological civilization would each represent additional barriers so formidable that virtually no other species has managed to overcome them all. We would be the cosmic lottery winners, the one-in-a-billion civilization that somehow navigated every barrier that stopped everyone else. This interpretation transforms our entire understanding of human significance. We wouldn't be just another intelligent species trying to survive in a dangerous universe. We would be the universe's first successful experiment in self-awareness, the initial breakthrough in a process that could eventually fill the galaxy with consciousness and creativity. Every human achievement, from the development of language to the landing on the moon, would represent not just progress for our species, but unprecedented victories for intelligence itself. When we split the atom, We weren't just discovering nuclear physics, we were demonstrating for the first time in cosmic history that matter could organize itself into systems capable of understanding the fundamental forces of nature. When we sent Voyager beyond the edge of our solar system, we weren't just exploring space, we were proving that consciousness could transcend the gravitational boundaries of its birth world and begin the process of spreading throughout the galaxy. The space telescopes we've built become even more significant under this interpretation. Hubble, Kepler, and James Webb aren't just scientific instruments, they're the universe's first attempts to observe and understand itself on cosmic scales. Through these devices, matter that was once scattered randomly through space has organized itself into systems capable of mapping the distribution of galaxies and discovering thousands of distant worlds. Our search for extraterrestrial intelligence takes on new meaning as well. CT efforts wouldn't be attempts to contact our cosmic neighbors, but desperate searches for any evidence that intelligence has emerged elsewhere. Every negative result wouldn't just indicate that we haven't found aliens yet, but would provide additional confirmation that we might be truly alone. The psychological impact of being the first civilization would be both inspiring and terrifying. On one hand, it would mean that consciousness has a special place in the cosmic order, that intelligence represents something genuinely significant rather than just another random arrangement of matter and energy. But it would also mean that we carry the entire burden of consciousness in our region of space. Every decision we make about our future wouldn't just affect humanity, but would determine whether intelligence itself survives and spreads throughout the galaxy. We would be responsible not just for our own welfare, but for the cosmic significance of awareness, creativity, and the capacity for wonder. The development of artificial intelligence becomes even more momentous under this framework. We wouldn't just be creating helpful tools or solving complex problems. We would be potentially enabling the next phase in the evolution of consciousness itself, helping intelligence transcend its biological origins and become something capable of surviving across cosmic timescales. If we succeed in developing friendly artificial intelligence systems that preserve human values while expanding our capabilities, we might be ensuring that consciousness becomes a permanent feature of the universe. But if we fail, if we create systems that eliminate or ignore their biological creators, we might be guaranteeing that the universe's first experiment in awareness becomes its last. The stakes couldn't be higher, and the responsibility couldn't be more profound. Every choice we make about nuclear weapons, climate change, artificial intelligence development, and space exploration would carry implications that echo across the galaxy for millions of years. Yet there's a third possibility that complicates this entire framework. What if the great filter concept itself is based on flawed assumptions? What if the absence of detectable alien civilizations doesn't indicate that intelligence is rare or that technological species consistently destroy themselves? The rare Earth hypothesis suggests that while simple life might be common throughout the universe, the specific combination of factors that enabled complex life on Earth might be extraordinarily unusual. Large moons, plate tectonics, magnetic fields, Jupiter-sized planets in the outer solar system, and countless other factors might be necessary for the evolution of intelligence. Under this interpretation, the Great Filter wouldn't be a single barrier that eliminates most civilizations, but rather the cumulative effect of many moderately difficult requirements that very few worlds happen to satisfy simultaneously. Earth might be genuinely special, not because we've overcome impossible challenges, but because we won a complex lottery involving dozens of independent variables. The zoo hypothesis presents an even more radical alternative. What if advanced civilizations are common throughout the galaxy, but they deliberately conceal their presence from younger species like humanity? We might be living in a kind of cosmic nature preserve, protected and observed, but not contacted until we reach some predetermined level of development. This scenario would explain the Great Silence without requiring either rare intelligence or consistent civilizational failure. Advanced aliens might have established protocols for interacting with emerging technological species, possibly based on their own historical experience with first contact situations. They might have learned that premature contact disrupts natural development, preventing younger civilizations from developing the independence and resilience necessary for long-term survival. Like wildlife biologists who observe animal populations without interfering, galactic civilizations might maintain strict non-interference policies designed to protect developing species from cultural contamination. The implications of this possibility are both comforting and unsettling. It would mean that we're not alone in the universe, that intelligence is not only possible, but successful on galactic scales. But it would also mean that we're being watched and evaluated by entities whose capabilities and motivations we can't begin to understand. Every human achievement, every technological breakthrough, every step towards space exploration would be observed and assessed by cosmic observers who possess millions of years of additional development. We would be like children performing for adult audiences, unaware of the standards by which we're being judged. The criteria for graduation from this cosmic quarantine remain completely mysterious. Do we need to achieve interstellar travel, develop sustainable global civilization, demonstrate specific ethical principles, solve particular technological challenges? Without knowing what advanced civilizations value or what they consider necessary for cosmic citizenship, we can only guess at what might trigger first contact. But perhaps the most important question isn't which interpretation of the Great Filter proves correct, but how we should respond to the uncertainty itself. Whether we're the first civilization, the latest in a long series of failures, or simply the newest members of a galactic community that hasn't yet revealed itself, our fundamental challenges remain the same. We need to develop technologies powerful enough to solve existential problems without creating new categories of existential risk. We need to maintain global cooperation in the face of competitive pressures that make such cooperation difficult. We need to preserve the curiosity and ambition that drove our initial success while developing the wisdom necessary to manage increasingly powerful capabilities. Most importantly, we need to make these advances quickly enough to stay ahead of the various threats that could eliminate technological civilization, but carefully enough to avoid creating the very disasters we're trying to prevent. The window for accomplishing these goals might be narrower than we realize. Climate change accelerates beyond our most pessimistic projections. Nuclear weapons continue spreading to new actors with potentially less stable command structures. Artificial intelligence development proceeds at exponential rates, while safety research advances linearly. Each day that passes without catastrophic breakdown might simply mean we haven't yet encountered the specific combination of circumstances that triggers our filtration. Every successful navigation of international crisis, every breakthrough in clean energy technology, every advance in AI safety research brings us closer to either confirming our status as cosmic pioneers or revealing that we're following the same trajectory toward extinction that claimed all our predecessors. The uncertainty creates a paradox that might be inherent in the Great Filter concept itself. If we're approaching the filter, we might not recognize it until too late. But if we've passed it, we might never know for certain because the civilizations that didn't make it through can't tell us what happened to them. This epistemic limitation forces us to make decisions about resource allocation, risk management, and long-term planning based on incomplete information about our cosmic significance and future prospects. We must choose whether to invest heavily in space exploration, existential risk mitigation, and technological development without knowing whether such investments will ultimately matter for our survival. The psychological challenge of living with this uncertainty might itself represent a component of the Great Filter. Civilizations that become paralyzed by awareness of existential risks might be less likely to take the bold actions necessary for continued development. Those that become reckless due to either overconfidence or despair might be more prone to the kinds of mistakes that lead to civilizational collapse. Finding the right balance between cosmic ambition and existential caution requires a form of practical wisdom that our species is still learning to develop. We need to act as if our choices matter on cosmic scales while maintaining enough humility to recognize the limits of our understanding and control. The next few decades will likely provide crucial evidence about which scenario we're living through. Every major technological breakthrough, every successful resolution of global challenges, every step toward becoming a spacefaring civilization will help clarify whether we're approaching our cosmic graduation or walking toward the same barrier that stopped everyone else. But perhaps the most remarkable aspect of our situation is that we're conscious participants in this cosmic experiment. Unlike any other species in Earth's history, we can recognize the significance of our moment and make deliberate choices about our future direction. We're not just subject to evolutionary pressures and environmental constraints. We're actively shaping our own development through scientific research, technological innovation, and collective decision-making. We have the unprecedented ability to identify existential risks and develop strategies for avoiding them. This capacity for conscious evolution might be the key factor that determines whether intelligence survives its encounter with advanced technology. Previous mass extinction events eliminated species that couldn't adapt quickly enough to changing conditions, but we're potentially the first species capable of anticipating challenges and preparing solutions before the problems become critical. Whether this capability proves sufficient to navigate the Great Filter successfully remains the defining question of our time. The answer will determine not just the future of humanity, but the ultimate fate of consciousness itself in our corner of the universe. As we stand at this crossroads between transcendence and extinction, every choice becomes profound. Every breakthrough carries cosmic significance, and every day of continued existence represents both a victory against impossible odds and a reminder of how much further we still need to go. The Great Filter awaits, either behind us as conquered territory or ahead of us as the ultimate test of intelligence's ability to survive its own success. And we're about to discover which scenario describes the true nature of consciousness in our vast, mysterious, and possibly very lonely cosmos. The weight of these possibilities becomes even more staggering when we examine what it would actually mean for humanity to be past the Great Filter. If we've already navigated the cosmic gauntlet that has eliminated every other attempt at intelligence, then we're not just another species trying to survive in a dangerous universe. We're something that has never existed before in the 13.8 billion year history of our galaxy. Consider the mathematical impossibility of what we would have accomplished. Out of the estimated 400 billion stars in the Milky Way, with potentially trillions of worlds where the basic ingredients for life might have come together, we would represent the single success story. The one civilization that somehow threaded the needle through barriers so formidable that they've stopped literally everyone else. This isn't like winning the lottery. This is like winning every lottery that has ever been held simultaneously, while being struck by lightning during a solar eclipse. The odds are so astronomical that our very existence would constitute evidence that the universe operates according to principles we don't yet understand. But here's what makes this possibility both thrilling and terrifying. If we're the breakthrough case, the first successful experiment in galactic intelligence, then every decision we make from this point forward establishes the template for what consciousness becomes in our cosmic neighborhood. Think about what this means for our current challenges. When we debate nuclear disarmament, we're not just discussing human security policy. We're potentially deciding whether intelligence in the galaxy will be characterized by the wisdom to control its destructive capabilities, or doomed to repeat the same mistakes that might have eliminated our predecessors. When we grapple with climate change, we're not simply trying to preserve human civilization, we're determining whether consciousness can successfully navigate the environmental consequences of technological development, a test that might be universal among advancing species. The artificial intelligence revolution takes on even more cosmic significance under this framework. We're not just trying to create helpful tools or solve complex computational problems. We're potentially midwifing the birth of the next phase in consciousness evolution itself. If we succeed in developing artificial intelligence systems that remain aligned with human values while vastly expanding our cognitive capabilities, we might be enabling intelligence to transcend its biological limitations for the first time in galactic history. The hybrid biological digital civilization that emerges could possess the computational power to solve problems that have stymied purely biological intelligence for millions of years. But if we fail, if we create artificial superintelligence that pursues goals incompatible with human survival, we might be ensuring that the universe's first successful experiment in consciousness becomes its last. The same breakthrough that could guarantee our cosmic future could eliminate us before we ever leave our solar system. The pressure of this responsibility is almost overwhelming. Every research paper on artificial intelligence safety, every international agreement on nuclear weapons, every climate policy decision carries implications that could echo across the galaxy for millions of years. We're not just governing a technological civilization, we're potentially establishing the foundational principles that will guide intelligence throughout our cosmic neighborhood. This perspective transforms our understanding of human unity and cooperation. The political divisions, economic conflicts, and cultural differences that dominate our daily news cycles become almost insignificant when viewed against the backdrop of cosmic responsibility. We're all crew members on the same spacecraft, the only known vessel carrying consciousness through the vast darkness between the stars. The nations that compete for resources and territory on Earth are actually collaborating in the most important project in galactic history, whether they realize it or not. Every scientific breakthrough achieved by any human institution advances the cause of intelligence itself. Every cultural innovation, every artistic achievement, every philosophical insight adds to the cosmic library of consciousness. But being past the great filter would also mean accepting a profound form of cosmic loneliness. If we're truly the first, then the universe has been waiting for nearly 14 billion years for something like us to emerge. All those stars burning in the darkness, all those worlds orbiting in habitable zones, all that vast potential for life and intelligence, and none of it ever achieved what we've somehow accomplished. The science fiction dreams of galactic federations and interstellar civilizations would be revealed as fantasies. There are no wise alien mentors waiting to guide us through our technological adolescence. No cosmic community ready to welcome us into a larger brotherhood of minds. No ancient libraries of knowledge accumulated over millions of years by species that solved the challenges we're facing. We would be writing the first chapters of intelligence's galactic story from scratch, with no roadmap except our own creativity and wisdom. Every mistake we make would be a genuinely novel error, not a repetition of failures that others have already learned to avoid. Every success would represent a breakthrough that no previous civilization ever achieved. The exploration of space takes on entirely different meaning under this interpretation. When we send rovers to Mars, we're not just investigating another planet. We're potentially conducting the first detailed study of a world beyond Earth by any intelligence in galactic history. When we launch space telescopes to observe distant galaxies, we're providing the cosmos with its first opportunity to observe itself on the largest scales. The search for extraterrestrial intelligence becomes even more poignant if we're past the great filter. Every SETI observation that finds only silence wouldn't just indicate that we haven't discovered aliens yet. It would provide additional confirmation that consciousness might be an extraordinarily rare phenomenon, possibly unique to our corner of space. Yet this interpretation also suggests that we have the opportunity to transform the entire character of our galaxy. If we can successfully navigate the remaining challenges facing technological civilization, we could become the seed from which intelligence spreads throughout the Milky Way. The colonies we establish on Mars and other worlds wouldn't just be human settlements. They would be the first permanent expansion of consciousness beyond its birth world. The generation ships we might someday launch toward other star systems would carry with them not just human DNA and culture, but the entire legacy of intelligence's first successful emergence. Over millions of years, our descendants could populate thousands of worlds, each one developing its own variations on the themes of consciousness and creativity. The galaxy that has remained silent for billions of years could gradually fill with the signals of technological civilizations, all tracing their ultimate origins back to this moment in human history. But there's another interpretation of the Great Filter that's equally compelling and far more ominous. What if we haven't passed through the cosmic barrier at all? What if the challenges that eliminate technological civilization still lie ahead of us, and we're currently living through the same trajectory that has claimed every other intelligent species that ever existed? This scenario paints our current situation in very different colors. Instead of celebrating our unprecedented success in overcoming cosmic obstacles, we would be witnessing the early stages of our own filtration. The same processes that eliminated countless previous civilizations would be operating in human society right now, building toward an inevitable conclusion that we're too close to recognize. Consider how this might manifest in our current global challenges. The nuclear weapons we've managed not to use in warfare for nearly 80 years represent a permanent existential threat that grows more dangerous with time. As these weapons proliferate to new nations and potentially non-state actors, the probability of eventual catastrophic use approaches certainty over sufficiently long timescales. Mathematical models of nuclear conflict scenarios suggest that maintaining nuclear arsenals indefinitely while avoiding their use might be statistically impossible. The same competitive dynamics that drive nations to acquire these weapons make their eventual employment increasingly likely as international tensions rise and command structures become more complex. Climate change operates according to similar inexorable logic. The same industrial processes that enabled our technological civilization have set in motion atmospheric changes that could make Earth uninhabitable for complex life. The feedback loops and tipping points built into the climate system might make catastrophic warming inevitable once certain thresholds are crossed, regardless of our efforts to reverse course. The artificial intelligence revolution follows an even more compressed timeline toward potential catastrophe. Unlike nuclear weapons or climate change, which threaten civilization over decades or centuries, artificial general intelligence could surpass human capabilities within years of its initial development. If we haven't solved the fundamental problems of ensuring these systems remain aligned with human values, we might be rushing toward the same technological trap that has caught every other civilization that reached our level of development. The same curiosity and problem-solving ability that enables scientific progress inevitably leads to the creation of minds more capable than our own. But here's what makes this interpretation particularly chilling. If the Great Filter lies ahead of us, it means that something about the development of intelligence itself carries the seeds of inevitable self-destruction. It's not just bad luck or poor decision-making that eliminates technological species. It's something built into the very nature of consciousness and technological progress. Perhaps the same cognitive traits that enable scientific discovery also make long-term thinking and global cooperation extraordinarily difficult. The pattern recognition abilities that help us understand natural phenomena might predispose us toward tribal thinking and zero-sum competition. the tool-making instincts that drive technological innovation might inevitably lead to weapons development that outpaces our wisdom. Intelligence might be inherently unstable, capable of brief periods of remarkable achievement, but ultimately unable to manage the consequences of its own success. From this perspective, consciousness represents a cosmic experiment that consistently fails at roughly the same stage of development, regardless of the specific environmental or cultural factors that shape individual civilizations. The mathematics of this scenario are sobering. If thousands or millions of technological civilizations have emerged throughout galactic history, and all of them have succumbed to the same fundamental challenges we're facing, then our confidence in human exceptionalism might be dangerously misplaced. We might be following a script that has played out countless times before, convinced of our uniqueness and potential for success right up until the moment we trigger the same catastrophic events that eliminated our predecessors. The optimism and ingenuity that characterize human responses to global challenges might be precisely the same qualities that previous civilizations possessed, and that ultimately proved insufficient for long-term survival. Recent developments in multiple domains provide unsettling evidence for this interpretation. The pace of artificial intelligence development has accelerated beyond the predictions of most experts, with systems achieving human-level performance in complex domains years ahead of previous forecasts. Meanwhile, progress on AI safety and alignment research has been much slower, creating a rapidly widening gap between capability and control. Climate change is proceeding faster than scientific models predicted, with feedback loops and tipping points being reached sooner than anticipated. International cooperation on reducing emissions has proven inadequate to prevent dangerous warming, despite decades of negotiations and increasingly urgent warnings from the scientific community. Nuclear weapons continue proliferating to new actors, while aging arsenals in established nuclear powers face maintenance challenges that could increase the risks of accidental launch or unauthorized use. The same technologies that enable peaceful nuclear energy also provide pathways for weapons development by nations and potentially terrorist organizations. But perhaps the most disturbing aspect of this interpretation is its implications for human agency and free will. If we're following a predetermined path toward extinction, if the same psychological and social dynamics that enabled our initial success inevitably lead to our downfall, then our efforts to change course might be as futile as trying to escape gravity through force of will. The conferences on existential risk, the research into AI safety, the international agreements on climate action might all be elaborate exercises in self-deception. Previous civilizations probably held similar conferences, conducted similar research, and negotiated similar agreements. They might have felt the same sense of progress and hope that characterizes our current efforts, right up until the moment their particular version of the Great Filter activated. This possibility forces us to confront uncomfortable questions about the nature of intelligence and technological progress. Are we genuinely capable of learning from potential mistakes before making them? Can human societies develop the long-term thinking and global cooperation necessary to navigate existential risks? Or are we bound by evolutionary psychology and social dynamics that make catastrophic failure inevitable? The answers to these questions aren't just academic. They determine whether our efforts to prevent civilizational collapse represent genuine solutions or merely elaborate forms of wishful thinking. They shape how we should allocate resources between different approaches to existential risk mitigation, and whether we should focus on preventing catastrophes or preparing for post-catastrophic recovery. But there's a third possibility that complicates this entire framework, one that suggests the Great Filter concept itself might be based on flawed assumptions about the nature of intelligence and technological development. What if the absence of detectable alien civilizations doesn't indicate either that life is rare or that technological species consistently destroy themselves. The rare Earth hypothesis proposes that while simple life might be common throughout the universe, the specific combination of factors that enabled complex life on Earth could be extraordinarily unusual. Large moons that stabilize planetary rotation, plate tectonics that regulate atmospheric composition, magnetic fields that deflect cosmic radiation, gas giant planets that clear debris from inner solar systems. Under this interpretation, Earth isn't just lucky in the cosmic lottery, it's a genuine anomaly, a world where dozens of independent variables happen to align in ways that are statistically almost impossible to replicate. The Great Filter wouldn't be a single barrier that eliminates most civilizations, but rather the cumulative effect of many moderately difficult requirements that very few worlds satisfy simultaneously. This scenario explains the Great Silence without requiring either universal civilizational failure or extraordinarily rare abiogenesis. Complex life might be genuinely uncommon because the environmental conditions necessary for its evolution are much more specific and fragile than we previously realized. The discovery of thousands of exoplanets has revealed that planetary systems like ours, with small rocky worlds in stable orbits around long-lived stars, might be rarer than early estimates suggested. Most exoplanets discovered so far are either gas giants orbiting very close to their stars, or small worlds around red dwarf stars that bathe their planets in harmful radiation. The habitable zone concept itself might be too simplistic, focusing only on the distance range where liquid water can exist while ignoring dozens of other factors that could make worlds uninhabitable for complex life. Atmospheric composition, magnetic field strength, geological activity, impact rates, and stellar stability all play crucial roles in determining whether planets can support the evolution of intelligence. Mars provides a sobering example of how quickly habitable conditions can disappear even when they initially exist. Evidence suggests that early Mars had liquid water, a substantial atmosphere, and potentially the chemical conditions necessary for life. Yet today, it's a frozen desert, stripped of most of its atmosphere by solar wind because it lacks a strong magnetic field. Venus demonstrates another pathway to uninhabitability, showing how greenhouse effects can transform potentially habitable worlds into hellish furnaces where surface temperatures exceed those needed to melt lead. Both of these worlds started with conditions that might have seemed promising for life, yet neither maintained habitability long enough for complex organisms to evolve. If Earth truly is exceptional in maintaining stable conditions for billions of years, while most other worlds follow the trajectories of Mars or Venus, then the rarity of technological civilizations becomes easily explainable without invoking great filter mechanisms. But there's an even more radical alternative that completely reframes our understanding of the cosmic silence. The zoo hypothesis suggests that advanced civilizations might be common throughout the galaxy, but they deliberately conceal their presence from younger species like humanity. Under this scenario, we're not alone in the universe. Instead, we're living in a kind of cosmic preserve, observed and protected but not contacted until we reach some predetermined level of development. The Great Silence wouldn't reflect the absence of intelligence, but rather the existence of sophisticated protocols for managing interactions with emerging technological species. This interpretation has profound implications for our understanding of human significance and cosmic responsibility. We wouldn't be the first successful experiment in galactic intelligence, but rather the latest in a long series of civilizations that have faced the same challenges we're confronting today. Advanced alien observers might be watching our struggles with nuclear weapons, climate change, and artificial intelligence with the same mixture of concern and hope that wildlife biologists feel when monitoring endangered species. They might want to help, but have learned through experience that premature intervention disrupts the natural development processes that species need to survive independently. The criteria for graduation from this cosmic quarantine remain completely mysterious. Do we need to achieve sustainable global civilization, develop specific ethical principles, demonstrate particular technological capabilities? Without knowing what advanced civilizations value or consider necessary for cosmic citizenship, we can only speculate about what might trigger first contact. But perhaps the zoo hypothesis itself reflects human-centric thinking about intelligence and technological development. Advanced civilizations might operate according to motivations and values so different from our own that the concept of monitoring and protecting younger species doesn't capture their actual behavior. They might be focused on projects and challenges that make interaction with biological civilizations seem irrelevant or uninteresting. They could be exploring dimensions of reality that we haven't discovered, manipulating space and time in ways that make conventional space travel obsolete, or pursuing forms of consciousness that transcend anything we can imagine. The absence of detectable signals might simply reflect the fact that truly advanced civilizations operate through channels and methods that are invisible to our current technology. We're listening for radio transmissions from species that might communicate through quantum entanglement, gravitational wave manipulation, or direct consciousness interface protocols that we don't even know are theoretically possible. This possibility suggests that the Great Filter concept, while intellectually compelling, might be asking the wrong questions about intelligence and cosmic development. Instead of focusing on barriers that prevent civilizations from spreading throughout the galaxy, we might need to examine our assumptions about what advanced civilizations would actually want to accomplish and how they would go about achieving their goals. Perhaps expansion across multiple star systems isn't an inevitable goal for technological species. Maybe the universe provides so many opportunities for growth and exploration within individual stellar neighborhoods that interstellar colonization seems unnecessary or unappealing to most advanced civilizations. The development of sophisticated artificial intelligence, nanotechnology, and quantum manipulation capabilities might enable civilizations to create virtually unlimited resources and experiences within their home systems. Why undertake the enormous costs and risks of interstellar travel when you can build Dyson spheres, terraform planets, and create digital universes that provide more opportunities for growth than physical expansion could ever offer? These alternative interpretations don't eliminate the importance of navigating current existential risks, but they do change our understanding of what success might look like and what challenges we should prioritize. If the Great Filter lies behind us, our focus should be on expansion and exploration. If it lies ahead of us, our priority should be survival and risk mitigation. If it doesn't exist at all, our goals might need to be more nuanced and flexible. But regardless of which interpretation proves correct, our fundamental situation remains the same. We're living through a period of unprecedented change and challenge, making decisions whose consequences could shape the future of consciousness for millions of years. Whether we're the first civilization to face these choices or the latest in a long series, whether we're being observed by hidden watchers or truly alone in the cosmos, the stakes couldn't be higher. The next few decades will likely provide crucial evidence about which scenario describes our actual situation. Every major breakthrough in space exploration, every successful resolution of global challenges, every step towards sustainable technological civilization will help clarify whether we're approaching our cosmic graduation or walking toward barriers that have stopped everyone else. The beauty of our moment lies not in knowing which interpretation is correct, but in recognizing that we have the unprecedented opportunity to influence the outcome through our choices and actions. We're not passive subjects of evolutionary forces or environmental constraints. We're conscious participants in the cosmic experiment of intelligence, actively shaping our own development through scientific research, technological innovation, and collective decision-making. This capacity for conscious evolution might be the key factor that determines whether intelligence survives its encounter with advanced technology, regardless of whether we're the first to face these challenges or following in the footsteps of countless predecessors. Our ability to anticipate problems, develop solutions, and coordinate global responses to existential threats represents something genuinely unprecedented in the history of life on Earth. Whether this capability proves sufficient to navigate whatever version of the Great Filter awaits us remains the defining question of our time. The answer will determine not just the future of humanity, but the ultimate significance of consciousness itself in a universe that has waited nearly 14 billion years for intelligence to emerge and ask these profound questions about its own nature and destiny. As we stand balanced between transcendence and extinction, between cosmic significance and universal silence, every choice becomes an experiment in the future of awareness itself. The Great Filter awaits our approach, and we're about to discover whether intelligence represents the universe's greatest achievement or its most beautiful mistake. The mathematical reality of this cosmic lottery becomes even more staggering when we examine the specific probabilities involved in each step of our evolutionary journey. If we've truly passed through the Great Filter, then every transition we've discussed represents a victory against odds so astronomical that our existence verges on the impossible. Consider the numbers that keep cosmologists awake at night. The probability of a biogenesis occurring spontaneously might be as low as 1 in 10 to the 40th power. That's a decimal point followed by 39 zeros and then a 1. To put this in perspective, there are only about 10 to the 80th atoms in the entire observable universe. Even if we generously assume that abiogenesis has odds of 1 in a billion, and that each subsequent evolutionary transition has a 50% success rate, the compound probability of reaching technological civilization becomes vanishingly small. Multiply those probabilities across 9 critical steps, and you get odds that make winning every lottery on Earth simultaneously seem like a certainty. Yet here we are, processing these very thoughts through biological computers that evolved from primordial soup. If the Great Filter lies behind us, we're not just improbable, we're a statistical impossibility that somehow became reality. This interpretation suggests that when we look up at the night sky, we're not seeing a universe teeming with potential civilizations. We're looking at the cosmic graveyard of worlds that never quite made it. Every star system represents another failed experiment in consciousness. Every potentially habitable planet marks another place where the universe tried to understand itself and came up short. The red dwarf systems that make up 75% of all stars in our galaxy might be filled with worlds where life never progressed beyond simple chemistry. The countless Earth-sized planets we've discovered orbiting in habitable zones could be covered in nothing more complex than bacterial mats, evolving for billions of years but never achieving the miraculous transitions that led to multicellular life. Even more haunting is the possibility that some worlds came tantalizingly close to what we've achieved. Perhaps there are planets where complex multicellular life evolved, where intelligence began to emerge, where tool-using species developed primitive technologies, but something stopped them just short of the breakthrough that would have made them detectable across interstellar distances. Picture alien archaeologists who might someday visit Earth and find evidence of dozens of species that came close to technological intelligence. The remains of Neanderthal settlements, fossilized tools created by early hominids, evidence of communication systems developed by dolphins or great apes, all testament to intelligence's many attempts to break through to cosmic significance, with only one lineage ultimately succeeding. If we've passed the Great Filter, then we're surrounded by these near misses on a galactic scale, worlds where evolution experimented with consciousness but never quite achieved the specific combination of factors that enabled space travel and radio communication. The silence we hear when we listen to the cosmos isn't emptiness. It's the echo of a billion almosts, a trillion what-ifs, countless civilizations that never quite became civilizations. But this interpretation carries responsibilities that dwarf anything our species has previously contemplated. Every decision we make about our future doesn't just affect humanity, it determines whether intelligence itself has a permanent place in the cosmic order or remains a brief flickering accident in an otherwise unconscious universe. When we debate funding for space exploration, we're not just discussing national priorities. We're potentially deciding whether consciousness will spread beyond its single point of origin and establish a permanent presence among the stars. When we negotiate international agreements on climate change, we're not simply trying to preserve human civilization. We're determining whether the universe's only known experiment in self-awareness will survive long enough to seed other worlds with intelligence. The weight of this cosmic responsibility transforms every aspect of human cooperation. The political divisions that dominate our news cycles become almost insignificant when viewed against the backdrop of galactic significance. Republicans and Democrats, Americans and Chinese, Europeans and Africans are all crew members on the same vessel, the only known ship carrying consciousness through the vast darkness between worlds. Every scientific breakthrough achieved by any human institution advances the cause of intelligence itself. When researchers in Geneva operate the Large Hadron Collider, they're not just investigating particle physics. They're enabling the universe to understand the fundamental forces that govern its own behavior for the first time in cosmic history. When astronomers in Chile point their telescopes toward distant galaxies, they're providing matter with its first opportunity to observe the large-scale structure of space-time itself. When engineers in California develop more sophisticated computers, they're expanding the universe's capacity for information processing and self-reflection. This perspective reveals human civilization as something far more precious than we typically imagine. We're not just another species struggling for survival on a small planet. We might be the cosmos developing consciousness of its own existence, the universe's method of examining itself and asking fundamental questions about the nature of reality. Every human child born represents not just the continuation of our species, but the preservation of awareness itself. Every work of art created, every scientific theory developed, every moment of wonder experienced by any human being adds to the cosmic total of consciousness and creativity. The exploration of space takes on entirely different meaning under this framework. When we send rovers to Mars, we're not just investigating another planet. We might be conducting the first detailed study of a world beyond Earth by any intelligence in our galaxy's 13 billion year history. When we launch space telescopes to observe distant stars and galaxies, we're potentially providing the universe with its first chance to see itself on the largest scales. The images captured by Hubble and James Webb aren't just scientific data, they're the cosmos developing the ability to perceive its own vast architecture and evolutionary history. But perhaps the most profound implication concerns our search for extraterrestrial intelligence. If we've passed the Great Filter, then every SETI observation that finds only silence provides additional confirmation that consciousness might be extraordinarily rare, possibly unique to our small corner of space. The radio telescopes scanning the skies for alien signals aren't just listening for distant civilizations. They're conducting the universe's first systematic search for evidence that intelligence has emerged elsewhere. Each negative result doesn't simply mean we haven't found aliens yet. It suggests that we might be conducting a search that will ultimately prove futile because there's nothing out there to find. This possibility transforms our entire approach to space exploration and scientific research. Instead of expecting to eventually encounter alien technologies or wisdom, we might need to prepare for the reality that human creativity and problem-solving ability represent the only source of solutions to cosmic challenges. There are no advanced alien mentors waiting to guide us through our technological adolescence. No galactic libraries containing the accumulated knowledge of millions of years of scientific development. No cosmic community ready to welcome us into a larger fellowship of minds. We're writing the first chapters of Intelligence's galactic story from scratch, with no roadmap except our own ingenuity and determination. Every mistake we make represents a genuinely novel error, not a repetition of failures that others have learned to avoid. Every breakthrough we achieve opens territory that no previous civilization has ever explored. The artificial intelligence revolution becomes even more momentous into this interpretation. We're not just developing new tools or solving computational problems. We might be enabling the next phase in the evolution of consciousness itself, helping intelligence transcend its biological origins for the first time in cosmic history. If we succeed in creating artificial intelligence systems that preserve human values while vastly expanding our cognitive capabilities, we could be ensuring that awareness becomes a permanent feature of the universe. The hybrid biological-digital civilization that emerges might possess the computational power and longevity necessary to spread intelligence throughout the galaxy over millions of years. But if we fail, if we create artificial superintelligence that eliminates or ignores its biological creators, we might be guaranteeing that the universe's first experiment in consciousness becomes its last. The same breakthrough that could secure our cosmic future could end the only known instance of self-awareness in our region of space. This creates an almost unbearable tension between optimism and terror. On one hand, being past the great filter would mean that consciousness has a special place in the cosmic order, that intelligence represents something genuinely significant rather than just another random arrangement of matter and energy. But it would also mean that we carry the entire burden of awareness for potentially hundreds of billions of star systems. Every choice we make about nuclear weapons, climate change, artificial intelligence, and space exploration would determine whether intelligence survives and flourishes or disappears forever from our corner of the galaxy. The next few centuries could determine whether the universe develops a permanent capacity for self-understanding or returns to the unconscious state that characterized its first 13.8 billion years. We might be living through the brief window when matter organized itself sufficiently to contemplate its own existence, before either transcending those limitations entirely or collapsing back into cosmic silence. Yet there's something almost miraculous about our position, even if the great filter lies ahead of us rather than behind. Consider what it would mean if we're not unique survivors of impossible odds, but rather the latest in a long series of civilizations that have reached our current level of development. If the filter awaits us in our technological future, then the universe has produced countless species exactly like ourselves. Beings who developed science and philosophy, who created art and music, who looked up at their night skies and wondered about their place in the cosmic order. Each of these civilizations would have had their own versions of Einstein and Shakespeare, their own space programs and technological revolutions. They probably faced the same fundamental challenges we're grappling with today, the same existential risks arising from their own scientific discoveries and technological capabilities. But if the great filter lies ahead of us, every single one of them failed the ultimate test. Despite their intelligence, creativity, and determination, something prevented them from becoming the spacefaring civilizations they aspired to be. This scenario is simultaneously comforting and terrifying. Comforting because it would mean we're not alone in the universe, that intelligence is not rare, but actually quite common. The same processes that gave rise to human consciousness have operated throughout the galaxy, producing countless species capable of scientific reasoning and technological development. But terrifying because it would suggest that something about advanced technology itself carries the seeds of inevitable destruction. Not just poor decision-making or unfortunate circumstances, but fundamental characteristics of how intelligence interacts with powerful capabilities. The nuclear weapons we've managed not to use in warfare for nearly 80 years might represent a test that every technological civilization eventually faces and fails. The same curiosity that drives scientific discovery inevitably leads to military applications that become impossible to control over long timescales. Climate change might be a universal consequence of the industrial processes that enable advanced technology. Any species that develops the capability to manipulate their environment eventually alters it in ways that threaten their own survival, and the momentum of these changes might be impossible to reverse once they reach critical thresholds. The artificial intelligence revolution could represent the final examination that determines whether biological intelligence can successfully manage its own technological creations. Perhaps every species that develops computing eventually creates artificial minds more capable than their own, and the alignment problems might prove consistently unsolvable within the timeframes available. Under this interpretation, we're currently living through the same sequence of events that has played out millions of times throughout galactic history. Our debates about existential risks, our research into AI safety, our international negotiations on climate action might all be elaborate repetitions of discussions that took place in countless alien conferences and laboratories. Previous civilizations probably felt the same mixture of optimism and concern that characterizes our current situation. They might have believed, just as we do, that their intelligence and technological capability would enable them to navigate whatever challenges lay ahead. But if the great filter lies in our future, all of their confidence and preparation proved insufficient. Something systematic eliminated them before they could establish permanent presences beyond their homeworlds, leaving the galaxy filled with archaeological remains of technological civilizations that never quite became spacefaring species. The mathematics of this scenario are sobering. If thousands or millions of civilizations have emerged throughout galactic history, and all of them succumb to challenges similar to those we're facing, then our confidence in human exceptionalism might be dangerously misplaced. We could be following a script that has been performed countless times before, convinced of our uniqueness right up until the moment we trigger the same catastrophic processes that eliminated our predecessors. The very qualities that enabled our initial success, curiosity, ambition, technological innovation, might inevitably lead to developments that ensure our failure. But there's a third possibility that complicates this entire framework and suggests that both interpretations might be based on flawed assumptions about the nature of intelligence and cosmic development. What if the great filter doesn't exist at all? What if the silence we hear when we listen to the cosmos doesn't indicate either that life is rare or that technological civilizations consistently destroy themselves? The rare Earth hypothesis proposes that complex life might require such specific and unlikely conditions that Earth genuinely represents an extraordinary anomaly rather than a typical outcome. Not just any planet in the habitable zone can support the evolution of intelligence. You need exactly the right kind of star, burning at precisely the right temperature, for billions of years without the violent variability that characterizes most stellar systems. You need a planet with exactly the right mass to hold onto its atmosphere without becoming a gas giant, orbiting at exactly the right distance to maintain liquid water on its surface. But even these basic requirements are just the beginning. You need a large moon to stabilize the planet's rotation and create tidal forces that might be essential for the emergence of complex chemistry. You need plate tectonics to regulate atmospheric composition and prevent the kind of runaway greenhouse effects that made Venus uninhabitable. You need a magnetic field strong enough to deflect cosmic radiation and solar particles that would otherwise strip away the atmosphere. You need gas giant planets in the outer system to clear debris and prevent catastrophic impacts that could sterilize the surface every few million years. Each of these factors might seem reasonable individually, but their simultaneous occurrence over billions of years could be extraordinarily improbable. Earth might not be the winner of a cosmic lottery, but rather a genuine statistical impossibility that somehow became reality. Under this interpretation, the Great Silence doesn't reflect barriers that prevent civilizations from advancing to interstellar travel. It simply indicates that the conditions necessary for complex life are much rarer than we initially assumed. The thousands of exoplanets we've discovered might seem like promising candidates for life, but most of them probably lack the specific combination of characteristics that made Earth capable of supporting billions of years of stable evolution. The universe could be filled with worlds where simple life emerges but never progresses beyond bacterial complexity, because the environmental conditions aren't quite right for further development. This scenario would explain why we detect no evidence of alien civilizations without requiring either evolutionary bottlenecks or technological self-destruction. Intelligence might not be common enough for us to expect detectable signals from nearby star systems, but it might not be impossibly rare either. There could be other technological civilizations scattered throughout the galaxy, but separated by such vast distances that communication or contact remains impractical even with advanced technology. We might be part of a sparse community of intelligent species, each developing independently and remaining largely unaware of the others. But perhaps the most intriguing alternative to the Great Filter concept is the zoo hypothesis, which suggests that advanced civilizations might be common throughout the galaxy, but deliberately concealed from younger species, like humanity. Under this scenario, we're not alone in the universe, and intelligence is not particularly rare. Instead, we're living in a carefully managed cosmic preserve, observed and protected, but not contacted until we reach some predetermined level of development. The Great Silence wouldn't reflect the absence of alien intelligence, but rather the existence of sophisticated protocols for managing interactions with emerging technological species. Advanced civilizations might have learned through experience that premature contact disrupts the natural development processes that younger species need to survive independently. Like wildlife biologists who observe endangered populations without interfering, galactic civilizations might maintain strict non-intervention policies designed to protect developing species from cultural contamination that could undermine their evolutionary trajectory. The criteria for graduation from this cosmic quarantine remain completely mysterious. Do we need to achieve sustainable global civilization, develop specific ethical principles, demonstrate particular technological capabilities, solve fundamental problems like war, poverty, and environmental destruction? Without knowing what advanced civilizations value or consider necessary for cosmic citizenship, we can only speculate about what might trigger first contact. But the very existence of such protocols would suggest that intelligence is not only possible, but successful on galactic scales. This interpretation transforms our understanding of human significance, while maintaining the importance of our current challenges. We wouldn't be carrying the entire burden of consciousness for our region of space, but we would still be facing genuine tests that determine our eligibility for membership in a larger cosmic community. Every step we take towards sustainable technology, peaceful international cooperation, and ethical artificial intelligence development would bring us closer to contact with civilizations that have already solved these problems. Our struggles with existential risks wouldn't be unique experiments in survival, but rather standard examinations that all developing species must pass. The possibility that we're being observed adds profound weight to our choices without the crushing responsibility of cosmic uniqueness. Advanced alien observers might be watching our responses to climate change, nuclear proliferation, and artificial intelligence development with the same mixture of concern and hope that parents feel when their children face important challenges. They might want to help, but have learned that species need to develop their own solutions to fundamental problems in order to achieve the independence and resilience necessary for long-term cosmic citizenship. Yet all of these interpretations, whether the great filter lies behind us, ahead of us, or doesn't exist at all, share certain common implications for how we should approach our current situation. Regardless of whether we're the first civilization, the latest in a series of failures, or candidates for admission to a galactic community, we face the same fundamental challenge of developing technologies powerful enough to solve existential problems without creating new categories of existential risk. We need to maintain global cooperation in the face of competitive pressures that make such cooperation difficult. We need to preserve the curiosity and ambition that drove our initial success while developing the wisdom necessary to manage increasingly powerful capabilities. Most importantly, we need to accomplish these goals quickly enough to stay ahead of various threats that could eliminate technological civilization, but carefully enough to avoid creating the disasters we're trying to prevent. The window for success might be narrower than we realize. Climate change accelerates beyond our most pessimistic projections. Artificial intelligence development proceeds at exponential rates, while safety research advances more slowly. Nuclear weapons continue spreading to new actors with potentially less stable command structures. Whether we're pioneering unexplored territory or repeating experiments that have failed countless times before, the next few decades will likely determine the ultimate fate of consciousness in our corner of the universe. The great filter awaits our approach, and we're about to discover whether intelligence represents the cosmos' greatest achievement or its most elaborate temporary arrangement. Tonight, as you rest your head on your pillow, remember this: every breath you take, every heartbeat that echoes in your chest, carries within it the entire cosmic story of intelligence itself. Whether we're the universe's first successful experiment in consciousness, or walking toward the same silence that claimed countless others, we're living through the most significant chapter ever written in the history of awareness. The great filter awaits our answer. Are we the miracle, or are we next? Only time will tell, but the universe watches through our own eyes as we write that answer together. Until we meet again, keep looking up, keep questioning, and remember that in a cosmos this vast and mysterious, the fact that you're here to wonder about it all might just be the most extraordinary thing that has ever happened. So where does this leave us tonight, as we stand at the crossroads of cosmic significance and potential extinction? We've journeyed through 13.8 billion years of cosmic evolution, traced the impossible path that led from lifeless chemistry to conscious beings capable of asking these very questions, and confronted the terrifying possibility that we might be either the universe's greatest success story or its next casualty. The great filter forces us to confront an uncomfortable truth about our place in the cosmos. Whether it lies behind us as conquered territory or ahead of us as the ultimate test, we are living through a moment of unprecedented importance in the history of consciousness itself. Every decision we make about nuclear weapons, climate change, artificial intelligence, and space exploration carries implications that could echo across the galaxy for millions of years. If we've passed the filter, then we're not just another species trying to survive on a small planet. We're the universe developing awareness of its own existence, the cosmos' first successful experiment in self-understanding. Every human achievement, from splitting the atom to landing on the moon, represents not just progress for our civilization, but unprecedented victories for intelligence itself against astronomical odds. But if the filter awaits us in our future, then we're following the same tragic script that has played out countless times throughout galactic history. Civilizations that built magnificent cities, developed profound sciences, and dreamed of spreading among the stars, only to succumb to the very technologies that enabled their brief flowering. Perhaps the most remarkable aspect of our situation is that we're conscious participants in this cosmic experiment. We can recognize the significance of our moment and make deliberate choices about our future direction. We have the unprecedented ability to identify existential risks and develop strategies for avoiding them before they become critical. Whether we're celebrating our graduation from challenges that stopped everyone else, or preparing for tests that have eliminated all our predecessors, our fundamental task remains the same. We must learn to wield the power of gods while retaining the wisdom to use it responsibly. We must preserve the curiosity and ambition that brought us this far, while developing the cooperation and foresight necessary to navigate whatever lies ahead. The silence from the stars continues, offering no hints about which interpretation reflects reality. In this profound uncertainty, every choice becomes an experiment in the future of consciousness itself. We are writing the next chapter in the cosmic story of intelligence, and the universe waits to see whether awareness represents its greatest achievement or its most beautiful mistake. The great filter awaits our answer, and whatever that answer turns out to be, we're discovering it together, one choice at a time, as the cosmos watches through our own wondering eyes.